Friends, today we are going to discuss about Introduction to Database Management System, that is DBMS. Before discussing, we'll discuss about what is database. Data. What is data? Data is nothing but it is a collection of raw fact. Collection of raw fact is nothing but unprocessed details are called as a raw fact. For examples, when your teacher is collecting your subject marks, all subject marks are called as a raw fact, unprocessed data. So here when I collecting the names of the students or names of the people or places, all these details are called as a data. All these details are unprocessed. Unprocessed process means what? Performing some calculations or manipulations are called as a process. Unprocessed means nothing we have performed on that data. It's a fresh details which we have collected it. For example, when I collect all your subject marks, all subject marks are called as a raw details. When I perform addition on it and when I find the total will be the processed data. That processed data is called as the informations. So usually we used to collect the data in a raw fact and later we'll do the processing. When you do the processing, your data becomes the informations. Then database. Database is nothing but the collection of related data is called as a database. See, once we collected all the data, we need to store all the data in a one secured place. So that place is a database. So we collect some related data. We never collect unrelated data. For example, to perform prepare your progress card, so I need to collect all your marks. So the marks is related with each subject. Okay. So when I collect all the data in a related form, that should be kept it under one table. That table will be in the database. So the database allows a user to store the data, retrieve the data and manage the data. So you can store large number of data into the database and retrieve in the sense whenever you want you can take your data, you can view the data, that is a retrieve. Then manage your data, that is maintaining your data. So how long you can keep your data? So you can keep it for long hours also, long days, long years. So any number of data can be stored or kept it under the database and you can keep it for many years also. Then DBMS. So DBMS is nothing but it is a system software which is used to manage the database is called as a DBMS. So simply the DBMS is called as a system software. You know about a software. Software is what? It is a collection of programs. So system software in the sense, so it is a platform which allows a user to access all your applications. Okay, so which controls the system, which controls the characters of applications or performance of applications is a system software. So this is a program which allows a user to access the database, store the data in the database and retrieve the data in the database. So again I will repeat, all the data will be stored in the database. To access that database, which becomes a bridge to us, DBMS becomes a bridge to us because it is a set of programs which allows a user to access everything. So example, MySQL and Oracle are the example of DBMS. What is DBMS? We already discussed this. So the database management system, this is the acronym of DBMS. It's a software for creating and managing database. So to create a database, how to create a database? By creating a data under the table is a creating database. Managing the database is storing all your data over there and whenever you want you can retrieve for all this. It allows a user and programmer to create, retrieve and update and manage the data. So with the help of DBMS only, you can able to store the data in the database, retrieve the data in the database, you can update in the sense you can make any modifications, deletions, any transactions you can done it in the database. Then what is database? Here database is a place where we can store retrieve and manage the data. So we all know about what is data. So in database, just like that, we cannot store all the data. If you store like this, the data will be in a scattered manner. So it provides you a good way to store all the related data together under one common name is called as a table. So in a database, all the related data will be stored under the name table, because it is very easy to access the data from the particular table. So it is very easy to identify, like a folder. So usually we used to create a folder and we used to keep all the files in a particular folder. So for what purpose we are creating a folder? To easy access your files. Okay, similarly, all the related data will be grouped under one common name that is called as a table. So which helps to identify which data is stored where and under what name. Evolution of DBMS. So when the DBMS becomes more popular, why it is invented? See, the concept of storing data started before 40 years in various formats. So the 40 years before itself, we started to store the data. So at the very beginning, the computer was invented for performing the calculation only. Okay, for the calculations performs only, computer were used. So later we started to store lot of data in the computer also. So for that, many techniques they were used. First, they used a punched cards. The punched card is like an input device. Okay, with the help of that punched card, we stored all the data in the computer. Then they followed a file system. So now the file system is a predecessor of our database system. So before we use a database, a file system were used. But only difficult in the file system is it is very difficult to maintain all the details under the file. So every data will be stored under the file. So it can be accessed in many ways, by indexing way in the sense by numbering all the files, by random way. So by randomly you can take any files, or in the sequential way. So one by one you can read the files. So these are the methods they were used in the file systems. So some limitations were there in the file system. So here we cannot store large number of data over there. So some limitations, some disadvantages over there. So what are the limitations? The data duplications. Duplications in the sense, the same data can be created by another user. Another person also create a same existing data. So while doing this, many copies of same data will be created. So the data redundancy is more in the file system. Then I maintenance in the sense, since we are storing all the files, all the data in the files, so we need to provide a access control. So providing access control and privilege control, the maintenance cost is very expensive. Security. Here in the file system, the security level is very low. So to overcome all these limitations only, the database system is invented. DBMS concept. Under the DBMS concept, so why we have started to use a DBMS, that is a database concept, to overcome the flaws in the file system. What are the flaws are there? We had data duplications there, and I maintenance there, and the security level is also very low. To overcome this, they thought to introduce a few properties in the DBMS. That properties is called as the ACID properties. So what is the expansion of ACID? A for atomicity, C for consistency, I for isolation, D for durability. So first we'll discuss about atomicity. Atomicity is a rule. It is a rule which always insists the transaction in all or nothing. Either it should be all or it should be nothing. I'll explain this. The transaction is nothing but whatever actions you are performing in the database, that is called as a transaction. For example, creating a data or storing a data or updating the data, all these are called as a transaction in the database. So when you are doing the transactions, either it should be executed all transactions should be executed or nothing should be executed. You should not execute in the partial way. This is the atomicity. So I'll give you one example for this. For example, you are going to book a ticket in airline. Okay, so in this case, what is the procedure? So you have to pay money for that. So once you pay the money, the seats will be reserved for this. Okay, so these two actions are to be done together only. Okay, so once you pay the amount for your ticket, immediately the seats will be reserved for you. So these two actions should be taken together. If one action is taken without the other, means it causes the error. So if I paid the money for the ticket, but the seat is not reserved for me. So in this case, what will happen? You will face some mistakes. The same seats can be reserved for many customers also. Okay, so this is atomicity. Either all the transactions should be executed or nothing should be executed. It should not be executed in the partial way. Whatever actions are there, every action should be executed together. Otherwise, no action should be executed. Next, consistency. So consistency, it ensures that changes in the data value to be constant at any instance. See, the consistency evaluates whether your data, whatever data you entered, is valid data or not. It checks whether it is a whether there is an inconsistent data is entered or not. That is a consistency. For example, you are entering a detail for gender. So usually what are the values can be entered in the gender form? So either the person should be the male or female or transgender. Okay, so the data should comes under any one of these three only. It cannot be any other data. So that is, other than these three, you cannot enter any data. Either you should enter a male or female or transgender. If you enter some other data which is not related to these three, you will get a error message. So the consistency, always a data should be consistent. Okay, so it should be the valid data which is related to your source, that should be entered in the database. The next one is isolation. Isolation is nothing but it is needed during the concurrent transactions. Concurrent transactions. What is a concurrent transactions? When multiple users accessing the same data source at the same time, that type of access is called as a concurrent transactions. So say we are accessing a Google. Okay, so the when you are accessing a Google, at the same time other persons also might have accessed a Google. So the same time many people are accessing the same objects. So this process is called as a concurrent transactions. So the isolations will be activated in these situations. Why it is activated? See, when many users are accessing the same object, we should not meet any conflict. Okay, so to avoid this, all the transactions are isolated, which never affects the other users' transactions. So whatever transactions in the sense what, whatever process you do, whatever actions you have taken, that is called as a transactions. Whatever transactions you are doing, yours will be isolated, that will not disturb the other transactions. Then durability. So durability is nothing but it recovers all your transactions during the failure of your database or failure of your systems. So whatever data, whatever transactions you have created, everything will be stored by default. Okay, so this durability provides, sometimes you are performing some transactions over there, suddenly your system crashed or something has happened or your database is collapsed. In such cases, whatever you have done, whatever transactions you have done, everything will be stored under as a non-volatile storage. Okay, so these four properties are very important for the DBMS. So what are the four properties? Acid properties: atomicity, consistency, isolations and durability. Atomicity means either all the transactions should be executed or nothing should be executed. Consistency, only the constant details should be entered, the valid details should be entered. Isolations, when multiple users are accessing the objects, all our transactions will be in a isolated mode. Durability, and by default it provides a durability concept to recover all our transactions during the failure of our system. Next, concurrency control and locking. So we already studied what is concurrency. So concurrency is nothing but many users are accessing the same data object at the same time. In such cases, there is a chances of getting an error. Some conflicts also can be occurred. Okay, so to prevent this, they should use as a access control and privileges. So the first the first person will get a first service. In such a way, they'll follow some procedures. Some privileges will be given to the persons. Okay, so when three users are accessing a same object, so who come first, they will give a rights to access that first. While accessing that, so we have to see that other users also should not be in a waiting queue. They also should get a access. So by giving the access, some control should be given. The first users can read the data. They cannot able to write anything in the database, but the second persons may get a chance of writing the data. It is locked for the reading data. So like this, some access control will be given to the user to avoid the errors or conflict during the concurrency time. The next one is database model. So we have a different database models are there. So we can store the data in the different models. Okay, so we have four things: hierarchical database model, network database model, relational database model, and object oriented database model. First we'll see about a hierarchical database model. In hierarchical database model, so the famous model was IMS, that is Information Management System. So this method was used by the IBMs. So IBM used here this model as Information Management System. See, it is like a parent-child relationship. It is like a parent-child relationship, and it is also like a tree structure. It provides a tree structure way. So parent-child relationship in the sense, the parent can have any number of child, but the child can have only one parent. In that manner, the tables will be created under the database. It just shows the structure of creating the tables in the database. So let's take this example. The root is nothing but the first table. So it contains only one root over here. So animal is the root of all the tables. So the animal can have any number of child table, that is child node. We can call it as a node also. So the fish and mammals are the child node of animal, but the fish can have only one parent, that is animal. The mammal can have only one parent, that is animal, but the fish can have any number of child also, that is marine and freshwater. Again, the mammals can have any number of child node, that is dog and cat. So do you understand this? In a hierarchical model, it is like a parent-child relationship. It also shows the tree-like structures. So from the root we'll get a stem, branches and leaves and everything. So similarly, the parent will be called as a root node. From that, many the child nodes or tables will be created. So the child must have only one parent. Then parent can have any number of child nodes. So here all the data will be stored in the form of records. Everything, all the data, whatever data we store, every data stored in the form of record. In the record it is a collection of fields. For examples, when I store, you can take this example. When I take animals, okay, so in the animals, in the sense, what are the records we can create? We can store all the names of the animals, or what are the parts. So parts, everything. Okay, so the name, parts. So the name and parts will be called as a field. Okay, so the collection of field is called as a record. The another example is when I take a students. So what are the when I take us to roll number 1. So the when I say roll number 1 means it should give you an entire detail about your roll number 1. That entire detail is called as a record. So what are the details will be there? The student register number, student name and his age and address. So all these are called as the collection of fields. Collection of fields is called as a record. So register number, name, age, address, all these 4 are called as a fields. When you group all these fields together, that is called as a record. So it stores the hierarchical database model. It stores a collection of records under the record type. Each field can store only one value. Advantages and some limitations in the hierarchical database model. So what are the advantages? Less redundant data. Redundant is nothing but repetitions, the duplications. So the same data can be created by many users also. For example, when you're storing your address, so if you all belong to Kovilambakam in this Kovilambakam and Chennai, so that Kovilambakam and Chennai can be repeated for many students. That is a redundancy of data. And efficient search. So it is very easy to search a particular data because we know the root path. Okay, so with the help of that path, easily we can reach the particular table and we can access the data. And data integrity. Data integrity is nothing but whatever changes you are doing in a data base, that should be reflected everywhere. So it should have a completeness and accuracy and consistency. Then security. It provides a security of your data in the database. Disadvantages is it's little complex to implement these concept in the database, and it difficult to handle the many to many relationship. Usually hierarchical databases performs a one to many relationship. One to many relationship means the parent can have many children, that is parent 1 can have many children, that is many. One to many relationship, but it finds a little difficult in the many to many relationship. The next one is network database model. So the first developed network database model is IDS, that is Integrated Data Store at Honeywell Company. So this is similar to your hierarchical database model. It is also like a tree-like structure, but only one difference is, so in hierarchical we said no, the child cannot have more than one parent. The child should have only one parent, but here the child can have any number of parents. So each member can have more than one. That is a network database model. In hierarchical, the parent can have many child, the child can have only one parent, but in network the child can have any number of parents. That is a network database model. So here they are using 3 components. What are the 3 components? Network schema. Network schema is nothing but it defines the structure of your database. Structure in the sense, what are the fields you are going to create and what are the data you are going to create. That is a structure. And subschema, the controls. What are the controls are allowed to view the database for the users. How the users can view the database. Language, the programs, which programs can support for accessing the database. So these 3 components are embedded in the network database model. So this is a structure. So ABC College is a parent. It has 2 child, that is department A and college library. So the college will have a department A and library, that is 1:n. 1:n is nothing but 1 to many. Again the student, So the student can access both the department as well as your college library. So this is n is to 1, that is many to 1. So now student has two parents. What are the two parents? Department A and college library. So this is only happen in the network database model. So the network database model support here many to many relationship. So the major advantages is it supports more relationship types. So we have, it supports one to many to one, and many to many relationship also. So easy data access, easily we can able to access the data, and here also it provides here independence and data integrity. The limitation is very difficult to design and maintain. See, since it is a large one, they'll find a little difficult to design and maintain the database. The next one is relational database model. So relational database model, it creates a relation between the two tables with a common field name, that is called as a relational database model. Okay, so when you have created a two table, so how you relate these two tables? Some common thing should be there to relate your two table. That common field is called as a keys. That key which is used to relate here both the tables. Oracle and DB are the commercial relational database model. So we have two terminologies, instance and schema. Instance is nothing but it is a table which is a collection of rows and columns. So I already told you that in database we used to store all the data in the form of table. So table which contains here rows and columns. Each row is called as a record, each column is called as a field. So another name is also there. Each row is also called as a tuple, and each column is called as a attribute. So I told you one example. When you store the details about a student, so what are the details we used to store? The student register number, name, age, address. The register number, name, age, address. All these four are called as a columns. So the column is also called as the attributes. The record, when I take the record number 1, it gives a particular the particular student's details. That record is called as a row. Okay, so that is also called as a tuple. So the relation table consists of unique attributes and tuples. So unique attributes in the sense your attribute should not be a duplicated one. It should not be repeated again. So if I store the informations, so I should have register number column for only once. Again register number 1, register number. Again I cannot create a two columns in the name of register number. So all the column names should be a unique. You should have one register number, student name, age. Again you cannot give the register number or student name. Okay, all the column names should be in the unique way. So it's an example for relational database model. Okay, so in the first table they have created item ID, order ID, item and amount. The next table contains customer ID, name, email. The third one contains order ID, customer ID, date and amount. Okay, so here you could see the common fields over here, that is the common column names. Which is a common names? For the first and third we have a common column is order ID. With the help of these order ID you can connect these two tables as a related, and the customer ID is also available in the third table. So this becomes a keys to connect the second table and third table. So like this we can create some relationship between the each table. The last one but not least, the object oriented database model. This is more popular nowadays. So here this object oriented database model which incorporates a combination of OOPS language and database technology. So we have a OOPS language concept, that is object oriented programming languages like Java, C++, Python, like this. Okay, so that concept will be used with a combination of database technologies. So here all the data will be stored under the objects. So in the normal database we see that all the data are stored under the table, but here everything is stored under the objects. So each object has an attribute and behavior. Similarly, the attribute is what? That is the column name. In such a way it stores all the details. So uses a small and reusable software known as an objects. So the advantages are it provides more efficient to manage the large number of different data types. So if you want to store large number of data or different data types should be stored in the database, this SOAP's concept of DB model is very easy and provides an efficient way, and here the security level is also very high. Students, I hope you could understand the concept of database DBMS and the types of database models. In the next class, we'll discuss about RDBMS. Thank you.